Oxygen. It's the most abundant element on Earth. It makes up about 21% of the air we breathe. It forms the ozone security blanket high above our heads, which shields us from the sun's harmful UV radiation. Half of the composition of our rocks and minerals is oxygen, and it's a key ingredient of the water we drink. In other words, without oxygen, life as we know it would not exist on Earth. But this is just the beginning of the story. Oxygen also has a wide variety of important industrial uses, including the manufacturing of steel, glass, paper, chemicals, pharmaceuticals, and petroleum products. Oxygen is also heavily used in the healthcare industry. With all the good oxygen provides, we can't overlook the fact that there are potential hazards associated with oxygen that we should be aware of. As the largest industrial gases company in North and South America, and one of the largest worldwide, Praxair is providing this video to help raise awareness about the potential hazards associated with oxygen and its safe use and handling. We will review oxygen's physical properties, explain the potential hazards of oxygen, and will describe the precautions or preventative measures you need to be aware of when using or handling oxygen. Safety considerations regarding oxygen are covered in greater detail in Praxair's publication, Storage and Safe Handling of Oxygen, in the Material Safety Data Sheet for Oxygen, on oxygen container labels, and in your company's safety program. But Praxair's commitment to safety goes beyond these printed materials. For example, Praxair has implemented a program called LEAP, which stands for Local Emergency Assistance Program. It's a program that gets you in touch with trained safety professionals whenever and wherever an emergency takes place. A phone call to any one of the LEAP emergency numbers puts you in contact with one of those professionals who stand ready to give you a prompt, safe, and effective solution to your situation. This video and these materials will help you better understand the right ways to handle oxygen and the safest ways to avoid its potential hazards. First and foremost, when we talk about oxygen, we're not talking about the air we breathe. Air is not oxygen, and oxygen is not air. Comparing the two would be like comparing apples to oranges. As stated before, air consists of about 21% oxygen. The majority of air consists of nitrogen at 78%. Almost 1% is argon, and the remaining tiny fraction includes trace amounts of carbon dioxide, methane, and other less abundant gases such as krypton, neon, and xenon. So there's quite a difference between oxygen and air. And that's the first rule to remember when it comes to working with oxygen safely. There are 3 properties of oxygen that you need to be aware of. First, as a gas, oxygen has no odor, no color, and no taste. But when it becomes a liquid at minus 297 degrees Fahrenheit, it takes on a pale blue tinge. Second, although oxygen in itself will not burn, it's a very powerful oxidizer, which means it supports combustion in other materials, but only if you have an ignition source and fuel. Once you have these 3, an ignition source, like a match, fuel, like a piece of paper, and oxygen, like the 21% floating around in the air, the fire triangle is complete, and suddenly you have a fire. If you replace the air feeding a fire with pure oxygen, the flame will soar, and so will the temperature. Industry uses oxygen's ability to support combustion in a wide variety of processes. Third, oxygen is highly reactive with materials like oil, grease, wood, and other combustible materials. For this reason, oxygen piping and system components must be kept free of contaminants. If there was a leak in those systems, the oxygen could react with the contaminants, and start a fire. Finally, pure oxygen is slightly heavier than air. So if there's an oxygen leak, it may accumulate at the ground level in poorly ventilated spaces. In some instances, if the concentration of oxygen is high enough, you don't even need a spark or a flame to start a fire. Rapid compression of oxygen or a sudden impact may be enough. Ask any diesel truck driver. Their engines operate by compression. No spark plugs are needed. Now that we have introduced the properties of oxygen, let's look at some of its potential hazards. The greatest hazard associated with oxygen is fire. As mentioned earlier, while oxygen itself does not burn, an oxygen-enriched atmosphere containing more than 23.5% oxygen can dramatically increase the risk of combustion of other materials and raise the temperature of any fire. Oxygen's ability to support combustion can cause materials that are safe to use in normal air, such as oil and grease, to become hazardous fuels in the oxygen-rich environment. Even a steel wool pad will burst into flame after being immersed in liquefied oxygen. Clothing and other materials saturated with oxygen are especially susceptible to fire. In one documented case, a maintenance worker performed a job inside a closed vessel with high levels of oxygen, which saturated his clothing. After the job was done, he left the vessel and decided to have a cigarette. He struck a match, the ignition source, and it ignited his oxygen-saturated clothing. As stated earlier, an oxygen-enriched atmosphere presents a fire hazard. In a confined space, the danger increases. A confined space is an area that is large enough and configured so an employee can enter and perform work. It has limited or restricted entrances and exits, and it's not designed for continuous human occupancy. It may also have poor air circulation. Confined spaces come in many forms, and they can be indoors or outdoors, such as the inside of a chemical reactor vessel, a rail car, or a storage tank. Even spaces that are usually considered safe, like sewers, tunnels, or vaults, can be confined spaces. These spaces also have the potential to become oxygen-enriched under the right circumstances. When liquid oxygen becomes a gas, it expands 860 times in volume. So even a small amount of spilled liquid oxygen can create a large volume of oxygen gas, a potential oxygen-rich environment and fire hazard. But the hazard isn't just limited to spills. When liquid oxygen is trapped between closed valves in a pipeline, expansion occurs as the liquid warms up. The resulting pressure can cause the line to burst. For this reason, oxygen containers and piping systems are designed and built to strict specifications and include pressure relief valves that vent gas safely if the pressure rises too greatly. An accidental release of pressurized oxygen can propel objects through the air at high speeds, severely injuring a person working nearby. The cold vapor can also cause frostbite, which brings us to our next hazard. Liquid oxygen is stored at a temperature of about -297 degrees Fahrenheit. This extreme cold creates the danger of severe frostbite if your unprotected skin comes in contact with the liquid oxygen, the piping system, or cold gas vapor. And frostbite, like burns, can result in permanent damage. Materials that are safe to use in normal conditions may become unsafe when exposed to the extremely cold temperatures of liquid oxygen. Rubber and plastic containers that hold liquids at room temperature can easily shatter when exposed to liquid oxygen. This racquetball illustrates the effect. Similarly, carbon steel, which is very strong under normal conditions, becomes brittle and loses its strength. Oxygen is essential for life. But prolonged exposure in areas where the concentration reaches 80% can cause breathing difficulties. At 100% for prolonged periods, you run the risk of your lungs deteriorating. Also, breathing oxygen at pressures not properly regulated can damage the lungs and affect the central nervous system. Some of the most important oxygen precautions involve reducing or eliminating fire hazards. Materials like oil and grease, which are safe in air, can become extremely flammable in an oxygen-rich atmosphere, or they can burst into flame when coming into contact with liquid oxygen. For these reasons, it's extremely important to keep combustibles and hydrocarbons away from oxygen piping systems and equipment. Oxygen equipment and systems need to be cleaned of contaminants before introducing oxygen. But standard hydrocarbon solvents such as mineral spirits can react with oxygen, so never even consider using these solvents for cleaning oxygen piping systems and their components. Only special cleaning agents approved for oxygen surfaces can be used to prepare oxygen contact surfaces. Contact your Praxair representative before attempting any cleaning for oxygen service. And always keep sources of ignition away from oxygen storage and work areas. Post appropriate warning signs at strategic locations. An oxygen spill or leak can present a serious fire hazard. Make sure a trained and qualified person inspects your oxygen system for leaks or damage on a regular basis. Because of oxygen's potential fire hazard, piping and storage systems are designed and built to strict codes and standards to prevent the oxygen from escaping. Every component of these systems is designed for suitability in oxygen service and for structural integrity. In addition, all oxygen piping systems and related equipment must be electrically grounded. Engineering controls such as these are very important to prevent oxygen leaks and fires. If there is a leak or spill, it's important to isolate the leak or spill area and evacuate personnel from the area. Contact the appropriate fire and emergency response personnel or notify the emergency team at Praxair. Don't try and do it yourself unless you've been trained and are qualified to do so. An oxygen-enriched atmosphere also presents fire hazards. In a confined space, this hazard is increased. The Occupational Safety and Health Administration, or OSHA, has very strict standards that define procedures for confined space entry, including measures that can prevent fire hazards. The standard requires companies to identify confined spaces and their hazards, develop a written confined space entry plan, train appropriate employees to safely perform entry, and provide the tools and equipment for the confined space entry team. Some key elements of the confined space entry standard deal with entry permit requirements, monitoring air inside the confined space for oxygen levels and hazardous gases, communication procedures, ventilation, and rescue procedures, to name a few. The bottom line? It's critical to identify confined spaces and follow your company's confined space entry plan as required by OSHA. It's also important to be aware of any sources of gas, electricity, hydraulics, pneumatics, or other hazardous energy sources that may be entering the confined space. They may have to be disconnected and locked out according to OSHA's lockout-tagout standard, which deals with the control of hazardous energy sources. The lockout-tagout standard requires companies to develop an energy control plan, which identifies workplace hazardous energy sources, including high-pressure gases. The energy control plan also includes procedures for controlling potential energy releases. Even after leaving an oxygen-enriched atmosphere, your clothing can still remain saturated with oxygen and present a fire hazard. That's why it's important to avoid any sources of ignition and immediately remove your work clothing after exposure to an oxygen-enriched environment. When working with oxygen in liquid or gaseous form, you'll need protection from the cold and pressure by wearing the appropriate personal protective equipment. Typical PPE includes safety glasses with side shields or goggles, which protect against pressure, covered by a full face shield to protect against splashing. Also wear loose-fitting insulated cryogenic gloves, flame-resistant long-sleeve shirt, and pants without cuffs. All clothing and PPE must be clean and free of contaminants before working with oxygen. The type of work being performed and your company's safety policies will determine the specific PPE to be used. As stated earlier, some materials become extremely brittle when exposed to the extreme cold of liquid oxygen. For this reason, only use containers, equipment, and systems designed to handle the extreme cold of cryogenic liquids. There are several general precautions to be aware of for safe handling of liquid and gaseous oxygen. Do not store it in a confined space. Instead, store and use oxygen in well-ventilated areas and away from oil, grease, and other combustibles, and where the temperature won't exceed 125 degrees Fahrenheit. Keep ignition sources away from oxygen storage areas. And never, under any circumstances, use oxygen as a substitute for compressed air. People who handle oxygen must be trained to understand its properties and its safe handling procedures. Additional important information about the safe use and handling of oxygen is available from your Praxair representative, the Praxair publication, Storage and Safe Handling of Oxygen, the Material Safety Data Sheet for Oxygen, the Compressed Gas Association, the American Society for Testing and Materials, the National Fire Protection Association, and the American Society of Mechanical Engineers. Working with oxygen systems can be performed safely, but only when you are aware of the hazards and follow the precautions spelled out in the variety of safety materials available. Your team of Praxair representatives can provide you a front line of defense against the hazards of oxygen, and in the end, keep you aware, alert, and safe on the job.
the ozone oxygen